Mrs. Bird back. Ute Lake Online Learning Center, Algebra 1, Semester 1, Unit 2, Lesson 3, Simplifying Expressions. For those of you who are Ute Lake Online Learning Center students, when you click on the lesson, and there's a whole bunch of stuff in this lesson, please pay attention to it, okay? But I'm going to go over some example problems mainly and talk you through it. However, some of the pages it talks about different properties, and I kind of want to go over those. They give you these boxes that state the property, and they give you some examples and stuff on the side. I printed this all out. But I just want to give you some keywords to think about. All right? So commutative property. Commutative property. I probably am not saying it right, but I always say it that way, commute, because I think about commuting to work and back. All right? There's commutative property of addition and commutative property of multiplication. It's basically the same thing. When you think about commuting, all right, if you live in a larger city and you go to work somewhere, or your mom goes to work somewhere, or whatever, then you commute to work. And then if you're in Albuquerque or a large city, you know, the commute was horrible today because traffic was awful. You know, be sure and listen to the news in the morning to get your commute updates, whatever. So what does that word mean? It basically means you're switching places. Okay? When you commute to work, you leave your house and go to work. You're still you. You don't change, but your location changes. Okay? And then at the end of the day, you commute back home. So you switch places. All right? You're still you, but where you are located has switched. So when we're talking commutative property of addition, finger in the way. All we're talking about is we've got stuff being added together. The A and the B could be variables, or the A and the B can be actual numbers. All right? And all we're doing is saying if we do A plus B, it's going to be the same number even if I switch places and do B plus A. So if I said 2 plus 3, we know that 2 plus 3 is 5, right? All right? Is that not the same thing as 3 plus 2? Is 5 not equal to 5? Right? So all we did is we switched places. You know? Instead of doing 2 plus 3, we did 3 plus 5. That's all that means. So with multiplication, it's the same thing, only we're multiplying. And it's the same thing. So if I did 2 times 3, does that not equal the same thing as if I did 3 times 2? Don't they both equal 6? Okay, so the order doesn't matter when you're doing these math operations, and that's the reason the order doesn't matter is because of this property, commutative property. Okay, so think of switching places. All right? My dog wants to help. I don't know why. Maybe later. Okay, that's Sally Girl. All right. The next property is associative property. We have associative property of addition and associative property of multiplication. All right, I like to think of this as changing groups. Okay? Again, I'll use like a big city analogy. If you live out here in the boondocks, you probably go to school and church or whatever with the same people. But I like to use this analogy, okay? So at school, maybe, you know, you hang out with a certain group of people at school, but then on Sunday when you go to church, you hang out with different people at church. All right? You're still the same person, it's just you're hanging out with different people, okay? And so what this is saying is that we're changing groups. It's very, very similar to commutative, only the clue is for all your quiz questions is there like more than 2? Do we have like parentheses, which are grouping things? So again, all we're saying is the order doesn't matter. So if this is 1 plus parenthesis 2 plus 3, right? if I do my order of operations, I do 2 plus 3, which is 5. And then I would add the 1 to it, and that would be 6. Well, is that not the same as 1 plus 2 parentheses plus 3? 1 plus 2 is 3. 3 plus 3 is 6. Okay? So again, the order doesn't matter as long as it looks like this. Everything is being added. You could have negative numbers in here. It doesn't matter. But the grouping, whatever you decide to add first doesn't matter because it'll all come out in the wash. Okay, so that's all that means. So we're just changing groups. Sometimes we do that in mental math. We like group things that are easy to do in our head. So we're using these parentheses in our head. Okay. So multiplication is the same thing. And this is where it's true. A lot of times we'll do tens in our head, but the order doesn't matter. So just notice that the grouping changes places, but the operations don't change, the numbers don't change. Okay, so associative property is changing groups. Okay, and then the next one is distributive property, which is huge. You use this so much in algebra. Okay. And it's kind of like dealing cards. Okay, with multiplication. I'm just going to put that in here, a little caveat. Multiplication. Okay? So what it's saying is that this is what you're going to see 9 times out of 10 when we get into the meat and potatoes of algebra. You're going to see stuff like this. And what you're going to do is you're going to do math to make it look like this. Okay, so all we're saying is that this guy out here is going to be multiplied to that guy, and this guy is going to be multiplied by that guy. So you're basically dealing the A to B and C. All right, it's like dealing cards. So if I did this with numbers, 2 parentheses, let's do easy stuff. Okay, so I would do distribution. Distribute the 2 to the 1. So that's the same thing as saying 2 times 1. Alright, the plus, we're still doing the plus, but we're going to distribute that 2 to the 3. So 2 times 3. And then we're going to do the math. Okay, so now we're going to do math. Alright, now when it's all numbers, usually we don't need to do this, or it's mental math that we've done. We're going to do this a lot with algebra. Okay? So the necessity of doing it seems stupid, or silly maybe is a better word than stupid. Why can't I just do my order of operations? Boom, right? 4 times 2, 8, instead of breaking it into little pieces. You can. But when you get into algebra, a lot of times you will see distributive property that looks like this. There's going to be a variable in there. I mean, I'm telling you, you're going to do this so much. All right? And just for now, just bear with me. Okay? And then we'll move on to other algebra stuff. So distributing properties, like dealing cards with multiplication. This is the card. These are the people playing. You distribute that card to everybody and then multiply. All right? And then you could also break it up, which some examples may show where you'd go backwards, but we'll wait till we get an example like that. Okay, so those are the main properties I wanted you guys to understand. It talks in this lesson about order of operations, so let me just list that. Order of operations, and a lot of times some of you may have heard PEDMAs. Oh, that's sorry. Okay, which is very, very common in teaching it. You probably learned it in 5th grade, whatever. Parentheses, exponents, division, multiplication, addition, subtraction. The problem that I have with PEDMAs is people want to do this in the order of the letters. So they want to divide before they multiply. They want to add before they subtract. Which you have to think of order of operations always left to right, just like you read. Okay? So what this means is you're going to do anything with parentheses. Okay, and they can be any kinds of grouping things. Later on, if there's stuff in here, this is considered a grouping symbol. Okay, absolute value. If there's stuff inside there that you can do math with, grouping symbols. Okay, you're going to do anything inside these grouping symbols first. This means exponents. After you take care of this stuff, you're going to take care of exponents. Exponents are the stuff raised to a power. So if you have a 2 squared, you're going to do that math. 2 squared equals 2 times 2. All right, you're going to do that math. All right, then you're going to multiply and divide at the same time, left to right. So it doesn't matter. It doesn't matter what comes first, but you're going to do. It doesn't matter. You can do multiplication if it comes first, then divide. Doesn't matter. Left to right, left to right, left to right. And then the last thing you're going to do is you're going to add and subtract. Again, the order doesn't matter. Just look at it like you're reading a book, left to right. Okay? So, if we did this problem, the first thing we got to take care of is our P, or parentheses. We're going to do math inside the parentheses first. So we're going to do -2 minus 5. All right? Use your calculator. I don't want to go into a lesson with positive and negatives right now. If you're not good with positive and negatives, just use your calculator. There's no shame. Okay? So -2 minus 5. Now I'm going to tell you that that's -7. All right? Now right here, right here, we just talked about distributive property and how the card on the outside is multiplied. This is a case you could do distributive property if you wanted to, but this time I'm not going to. I'm just going to do the stuff inside, but I want you to know that the 7 is multiplied to whatever that answer is. Okay, so we haven't done anything with this guy. We haven't done anything with a 7, but he's going to be multiplied. I'm just going to put a little multiplication symbol to this right here. This right here is -7, so I'm just going to write that as a -7, then plus 3. Okay. The next thing is exponents. So we're going to do 8 squared. Again, use your calculator, 8 squared, or know that it's 8 times 8. So 8 times 8 is 64. All right. Now, granted, I could do a couple of these things all at once, but for your sake, I'm going to do it step to step. Next thing is multiply or divide, left to right, left to right. Here's my multiplication. I'm going to multiply those two guys together. All right. Everything else I'm going to leave alone. This is going to end up being -49. All right, I'm going to put parentheses around that so we know that's a negative. That's very, very common in algebra, is putting parentheses around a negative so it stands out. Okay, it doesn't mean you have to do math there. It just says, hey, look at me, I'm a negative. See me? I'm a negative. All right, all that's left is adding. So we go left to right. All right, I'm going to cheat to make sure I don't make a mistake. All right. 64 plus a -49, and that's a 15, left to right. So 15 plus 3, and then 15 plus 3 is 18. Okay, that's your order of operations with my finger in the whole picture the whole time. Okay, left to right. If you will do that. Now you could put all of this in your calculator. All right, if you choose to put it all in your calculator, which it's a tool, use it to its extreme, there should be parentheses on your calculator. Okay, if there is, and you type it in exactly how it is. All right, 8 squared plus, you may have to put a times right here depending on your calculator. 7 times parentheses -2 minus 5 parentheses plus 3, because a calculator will use the order of operations every time if you put it in right. Okay, so FYI, there's nothing wrong with using your calculator. Okay, all right, so lots of order of operations problems in that thing. I want to look for simplifying expressions. Okay, simplify the expression. Okay, it's not an equation because there's no equal sign. It's an expression because it has globs of algebra. It's an algebraic expression. And so it has terms. All of these are terms. Some of the terms are algebraic terms. Some of them are constant, yada, yada, yada. Some have x's, some have y's. So before we start anything, let's go up to this problem here. You can combine terms by adding or subtracting only if the terms are like terms. Okay? I'm trying to do this with... What in the world does like terms mean? Like terms means they have the same variable, raised to the same power. Okay? So like terms, 2x and 3x are like terms because they both have x, and that x is just a single old x, or raised to 1 power. Okay? So these are like. Okay? If I had 2x squared and 3x, yeah, they both have x's, but this x is squared and this x is to the 1. If you don't, 1 is always invisible a lot of times. Okay? They're not the same, so I can't combine them. Okay? So not like. All right? X, 2x, and 3y are not the same. Notice it just has to do with the variable. Yeah, these numbers aren't the same, but that doesn't matter. All we care about is the variable when we're talking about like terms. Okay? So if they're like terms, then you're just going to do the math with the coefficients. So 2x plus 3x, I'm just going to do the math with the coefficients. 2 plus 3, that's going to be 5x. That's combining. I just combined like terms. Okay? Please remember, if there's just a Lone Ranger x, okay, there's really a 1 here. It likes to be invisible. So this is 1 plus 3. All right? Well, I won't say equals. So if I just have x plus x, how many x's I got there? I got 2 x's. Okay? Those are all like terms. So with that said, let's do this example right here. What I highly recommend is you write this problem down on a piece of paper and use a pencil or a colored pencil or a marker or whatever. Okay? So I've got x's and y's and things that don't have variables at all. So here's what I'm going to do. I'm going to go left to right. So I'm going to underline anything that has an x. So 3x, nope, 2x, and I'm going to underline the symbol in front of it. I'll explain why here in a minute. Boom, boom. Okay. Now then, that's all my x's. All right. Now I'm going to circle my stuff with the y's, and it's going out of focus for some reason. Okay, and I'm going to circle it along with the mathematical operation that's in front of it. Okay, so there's a y, and here's a y. Okay, and then what's left? These guys. Okay, these guys I'm going to put a square around with the operation that's in front of them. Okay. All right, now then, what I'm going to do, combining means add them exactly how they are. All right? So 3x plus 2x. 3 plus 2. 5x. Okay? 2y, a positive 2y, plus a 7y. So 2 plus 7, 8, 9. And everything's positive, so I'm going to put a plus sign in front of it. All right, and then finally, negative 2 plus 7. So negative 2 plus 7 is positive 5. And that is as simple as I can get because nothing else combines. And there's no equal sign, so I can't even solve it. But it is simpler because up here we had 1, 2, 3, 4, 5, 6 terms, and now we have 3. So that's simple. All right. Now then you notice that I circled, or I included the sign, the math operation that's in front of the term. Okay, once that plus acts not only as a plus, but as a positive symbol. All right? So when I separate things out, like I separated this -2 out, when I separate it out, that minus becomes a negative, -2. Okay? So that's why I got this 5. So that's why it's really, really important to circle or take the symbol that's right in front of it with it so that you get the right signs. Okay? If there's no negative here, that's a given. It's a given that it's positive. Okay? So that is simplifying expressions. Let's do one more. Let's do this one, and then we'll call it a day. Okay? Now this is pretty complex. But again, we're going to look at order of operations, and some of our properties are going to come into play. Okay? So if I can't actually do math here, right? Because they're not like terms. That's an x squared and that's an x. So I can't actually do math there. So my parentheses are stuck. So before I do anything, I want to get rid of the parentheses. It really screws things up. I can't simplify. The parentheses kind of keeps me from doing that because of the laws of math and the whole order of operations. Okay, but we learned about distributive property. All right, distributive property. So what we're going to do is we're going to get rid of those parentheses by using distributive property. Now then, I'm going to throw a bunch of stuff at you. I'm sorry, just this problem the way it is. When you're fixing to do distributive property and there's a minus sign, okay, and remember how on the last problem I told you, like if you separated this out, that was a negative. So change this to a plus here and stick a negative right there on that 3. Okay, that way you don't mess up the signs, okay? Because sometimes that -3, some people will attach it to the first term when they do distributive property, but they won't remember to take that negative on the second term in the distributive property. Okay, it's a very common mistake. I've seen it a million times. So my trick to you guys is, if anytime there's a minus sign, make it a plus a negative. And then you know for sure when you do your distributive property, you're distributing that -3 to both terms. Okay? So I'm going to rewrite everything here. I've got 9x squared plus -3 times x squared. So this becomes a -3x squared plus -3 times x. I think my camera's focusing on my pen and not on the problem, so it's getting, the focus is all funky. So I mean, amateur. Maybe by the time I get the end of all these videos, I'll be an amateur asking you guys to subscribe and all that good stuff. Anyway, so there, I took care of that. I'm just going to write everything down again. Okay, once you don't have parentheses, then you can go and do what I did in the last problem. And you can use colors too, if you want, especially when there's a bunch of different things we're going to be circling. Well, I think I'll probably use a color. So the very first thing I come across is something with an x squared. So remember, same variable, same exponent, those guys are like terms. Alright, so I'm going to put a square around the 9x, and I'm going to go ahead and put a square around the -3x squared. So this is a case where that sign right there comes in handy. And you see what we're going to do here in a minute, and you could already do it if you're seeing it, is you're going to add those two together. Okay, but let me go back. Let me keep going. So, all right, no more x squareds. All right, so the next thing in line is just an x. So I'm going to circle that guy and look for something else with an x right here. And I'm going to circle that guy with the sign there. Okay, I'm going to excuse me, I'm going to grab a marker. My next thing is the y's. So underline the whole thing, plus 4y. Oh, there's no other y's. Okay, that's okay. All right, and then let's see. Let me use a blue pen. The next thing is just the constants. So I'm going to circle the constants with blue pen. All right? Now remember, combining means adding. Okay? So let's go. 9x squared plus a negative 3x squared. So we're really just doing 9 plus a negative 3. And that would be a 6x squared. Okay? Those guys are gone. Then I've got a positive 1x and a positive 2x. So we're adding x plus 2x, so 3x. Remember, there's an invisible 1 here. Okay, that's a 1. Next is 4y. I didn't have anybody. He doesn't have any buddies, so we're just going to write him again. There's nothing we can combine him with. He's lonely. All right, next in line here is my constants, negative 3. And see, I'm not quite sure what to do. That's why, remember, it means add. So I'm going to do negative 3 plus a negative 5. That's why I circled this, the signs in front of them. Negative 3 plus a negative 5. All right, so that's a negative 8. Now then I can write plus a negative 8, or I can just write negative 8 like that. Either way, it's totally fine. Okay, you probably want to do this because if you wrote it as plus a negative and it's multiple choice, you're not going to see that over there. Okay, as you can see, they're all minus 8s. Okay. All right, and then finally, or no, not finally, that one's already gone. I already took care of those guys. All right, so that's it. Okay, 6x squared plus 3x plus 4y minus 8. Okay. So you can kind of see the answer choices, and you can kind of, I was like very, very tricky right here, and then trying to trip you up. Right? But I would if you will do this, use colors, circle your like terms with the signs, you can't go wrong. You can't go wrong. Okay? So that is lesson 3 for you. Hope that helps. Talk to you later. Bye.